Good everyone. I hope you guys have an amazing day. So what I'll do today, right before we jump into any kind of hands-on, I think it's good to understand Snowflake architecture. Um, so at least an overview, or at least I would expect that you need to know some foundational concept before we try to do any sort of hands-on. So this is a pretty good documentation. Obviously, I wanted to talk about the diagram side. Um, so as you can see, right, the Snowflake architecture, it's a hybrid of traditional shared disk and shared nothing database. So if you are someone who used the Teradata or Oracle back in the days, you would know the concept of the shared disk, right? Where, you know, you have a central data repository for persistent data, and which can be accessible, right, from all compute nodes. But at the same time, in today's era, we talk about the massive parallel processing and with the compute clusters. So if you wanted to perform massive queries, and at the same time you wanted to ensure that if you need to take care of the concurrent users, then you need to have support massive parallel processing, so you can process the queries, right? Um, where each node's, like as you can see here, right? Snowflake process queries using massive parallel processing, where each node in the cluster stores a portion of entire data set. Now, I will dive more into this diagram stuff, right? So, if I have to look at the architecture, right, I often say it's a three layers from this diagram. One is the storage, and then you have a compute, then you have your cloud services, right? So, I will explain from the storage, then I go to compute, then I go to the cloud storage, right? So if you look at the storage, right, the storage, Snowflake stored structured, like for instance, your tables with rows and columns. Then you have semi-structured, like JSON, XML. Then you have, unstructured data. For instance, image. You have documents, right? So one thing you need to understand, right, when you load your data into Snowflake tables, right, it automatically compresses, reorganizes into a columnar format, uh, and then divides into something called micro partitions, right? Now, which is all simple in theory. Now, you must be wondering, since we are talking about tables, what kind of tables we are talking about, right? Obviously, Snowflake tables. Uh, we have Snowflake tables, which is internal and it's optimized. Then you have, iceberg tables, something we call, which is data stored externally, but still you can query. Um, so I will get into the details, though, right? Just give you a context, right? You have a temporary table, then you have permanent tables, right? Um, so that's from a very basic perspective when you talk about the database storage. I mean, which is quite obvious, right, when you look at the screen. Then you have something called a compute, right? And in simple terms, I would say the machine that do the work. So Snowflake uses what we call virtual warehouse, right? Now, each warehouse, if you look at the warehouse, uh, it's a cluster of compute resource. Like for instance, your CPU, your memory, that runs your queries and transformation. Now, one thing to remember, though, right? Each warehouse is independent. So what that means is that one warehouse heavy job won't slow down another one. So that's a pretty good advantage, I would say. You can also, run your code, especially in this space, using any general purpose language, Python, Java, Scala, using Snowflake's Snowpark. We'll look into that. I just wanted to mention brief here. Um, so that's from a compute perspective, right? Then you have cloud services, right? You talk about security, where your identity and all the other stuff comes, right? I mean, this layer is the cloud service layer, right? Is usually responsible for user sign-in, your access control, your querying. parsing, query parsing, sorry, optimization, metadata, etc. Right? It handles the management parts of the services, so you only worry about your data and compute, which is pretty good. Now, you must be wondering, right? We have this separation of storage and compute. Why, right? So, the major benefit, right? Storage, obviously, your data storage. Um, your data stored in one place, and the compute clusters uh, can be sized up and down independently without impacting. You can have, many compute clusters for many teams, right? If you're dealing with all working on the same data without duplicating it. What that means is you got flexibility, scalability, and it's quite cost efficient, right? Now, one thing you need to understand, Snowflake is not just a data store which run queries, right? It supports wide range of workloads, right? It can do data engineering, as I mentioned the other day, that is ingestion, data transformation, right? Uh, and you have a concept called snow pipes. Then you have data analytics. You can run your SQL queries, SQL queries. Um, and then you can do artificial intelligence, right? Because data lives in Snowflake. You can build models and you can do training, inference without moving the data around. Um, so also you need to understand that Snowflake supports the cross cloud and cross-region setup where SnowGrid technology. So cross-cloud means it supports AWS, it supports Azure, it supports Google, right? Google Cloud. You can replicate data across regions, apply consistent governance, share data with other accounts and organizations. You can do all of this stuff, right? So that's in a very simple terms when it comes to your, um, you know, um, the Snowflake architecture. It's a pretty good resource, but I just wanted to give you a very, very basic overview before we jump into the real stuff, right? It's very important you understand, how the stuff works, and at least the three layers. You need to have a basic understanding. We'll get into the detailed part, but for now, this is just an overview. So that's pretty much I wanted to um, cover from a basic architecture stuff. Now, obviously, when you talk about the storage layer, you can talk about micro partitions. We can talk about metadata catalog. There are a lot of terms you will hear as you go along this journey. And, people often talk, when you talk about compute layer, you might talk about Snowpark, compute pools, all kind of terminologies get thrown around, but it's important to understand what that means. Even in the cloud service layer, like you get to hear about, SSO, resource manager, and all kind of stuff, right? So it's important that as we go along, we'll focus on that, right? Um, Also, one thing I just wanted to mention that might be an important information: all data in Snowflake is encrypted end to end with AES 256 encryption. And also, the customer managed keys are supported via Try Secret Secure, right? Um, so, yeah, that's one of the things you just need to understand. And obviously, it supports a lot of things, right? You can do caching, especially when it comes to compute. There are three kinds of caching. You have result cache, local disk cache, metadata cache. We'll look into that, right? So just don't get overwhelmed. So for now, just remember this is a three layer. You have database storage, you have compute store layer, you have cloud service, right? Each has its own function, right? And that's what makes Snowflake the most beautiful data warehouse in the cloud, right? And it's very efficient, it's very quick. You can query thousands of record in a fraction of seconds, right? Because of its architecture. Yeah, so that's pretty much I wanted to cover. Hope you guys have an amazing Monday. Adios.